Hello everyone, welcome to Voxels Animation. If you have been following the channel recently, you would notice that I have been posting a few fractal animations on Shorts. I have decided to make a video series to explain how some of them are generated. Today we will tackle the Mandelbrot Set animation. In order to achieve this, we will first review what complex numbers are. Then we will see how the Mandelbrot set is constructed. And finally, we will bring it to life through an animation. Complex numbers are mathematical entities that extend the concept of real numbers. They revolve around the imaginary unit I, such that I squared equals -1. Every number on the complex plane has two components, a real one represented by the x-axis and an imaginary one represented by the y-axis. Two complex numbers can be added together by adding the real and imaginary components, the same way we do for vectors. A complex number can also be represented in polar coordinates by using the exponential notation. The r here represents the distance to origin, while theta is the angle between the line from the origin and the x-axis. Two complex numbers can be multiplied by summing their angles and multiplying their amplitudes. Of course, we can also multiply two numbers by unfolding while remembering that I squared equals -1. One last operation we will need for the rest of this video is raising a complex number to the power of another complex number. We can define such operation by writing the base in polar coordinates, while writing the exponent in Cartesian coordinates. Then, since the exponential and the logarithm cancel each other out, and with a little math magic we can rewrite the operation as an exponential of a single complex number. Finally, we can use the famous Euler's formula to determine the real and imaginary components of this operation. Now that we reviewed complex numbers, we will be using them to represent pixels on the screen. The two components of each number represent the position of a pixel. For every complex number c, we can define the following recursive sequence. This sequence starts at 0, and next term can be computed by squaring the previous term and adding the number c. To generate the Mandelbrot set, we will color a pixel black if its corresponding sequence stays bounded. Otherwise, we will color it white. Let's try this on a couple examples. Let's calculate this sequence for the complex number 0.5i. We replace the number c in the formula, then we calculate the sequence term by term. Observing that the points clump together, we conclude that the sequence is bounded. Therefore, we'll color this point with black. Let us try again. This time with the number -1 plus 0.5i. This time the sequence keeps drifting further and further apart. We conclude that the sequence diverges, and thus we color it with white. If we replicate this process for all the pixels on the screen, we obtain a very familiar figure. the Mandelbrot set. To improve the aesthetics of the image, instead of coloring points either black or white, we can color them by how fast the sequence diverges, or by how many iterations it takes for the sequence to diverge beyond a certain radius. We can then choose different color mappings for different results. Looking back at the sequence that generated the Mandelbrot set, you might be wondering what is so special about such formula. The answer is not much. You can replace it with other functions and observe the resulting patterns. Back in our original formula, we can replace the exponent with different values, like 3, 4.5, -4, and even 5i. Now all that is left for us to do in order to generate our animation is pick a path on the complex plane on which our exponent will vary across. Leaving the real line tends to yield some pretty chaotic animations. Let's try to stay on it. You have reached the end of the video. If you enjoyed it, don't forget to subscribe for future content. Don't hesitate to check the shorts animations I made and suggest which ones you want me to explain in the comment section. You can also suggest new animations for me to make. See you in the next video. Take care.